Okay, in the third lesson of Unit 6, we are covering transformations of rational functions. So it is a packet where you work together in your groups, but I just want to go through each of them and make sure, or several of them, make sure you understand what the directions are asking you. So on this first problem, it says write each expression below as a sum or a difference. Okay, it's not a sum or a difference, it's just one term. So basically you're trying to break this thing up, and when you have just one term on the bottom, you can break it up, and not by making new numbers, but you break it up by putting each term in your numerator over the denominator. So now I have a sum or a difference. This is actually a difference, and you're good with that. So you will do each of those. This one, the difference between number 2 and number 1 is that we have actually two terms in the bottom and just one. So when you do this one, you're actually going to do the division that we talked about on the previous lesson, where you topple that thing over and it's going to be x minus 3 divided into 4x minus 7. So I'm going to let y'all work that on your own. Then the next one that we talked about was number 4. And this is um, one of our parent functions. So if you are absent and watching this, you need to know that this needs to be added to your parent function packet because it's one of those really important functions. Okay, so when you graph this, you have, let's go here, f of x equals 1 over x squared. And the first thing, rational functions, that's what we've been talking about. They are going to have asymptotes. Okay, and so we're thinking about what can x not be? X cannot be 0, so that's a vertical asymptote. And if there's a 1 on top, we also know that y can't be 0 because we've talked about that in previous lessons. So I have an asymptote here. Oh, well, that one good. I have an asymptote here and an asymptote here. Okay, and the other thing that we always talk about when we do our graphs are key points, because what's important in building our parent function library is that we know the shape of a graph and some key points on that. So the key points that we have are going to be an over and an up from the intersection of our asymptotes. So the main one we have are 1, 1, -1, and -1, because if you plug those in, 1 over 1 is 1, and 1 over -1 is -1. So you have these key points to begin with, but to distinguish that from what we're going to do later, it's always important and assists in your understanding if you know how to extend that. So if I were to go further, if I put in 2, okay, 1 over 2 is of course 1/2. And so at 2 I would have 1/2. And if I put in 1/2, then I hope you can see that that's 1 over 1/2, which is just the reciprocal of it. So it gets us to 2. And of course the negative sign is just going to put it on this side. And so my graph is going to look like this. Yeah, I'll see if I can kind of miss the points, but you got the idea. And then I have this one looking like this. Okay, so you have the general shape. Okay, I definitely want to see these points. This just helps you understand. Like I said, when we get to the back side, we'll have a different one. The other thing that you need to make sure you put on your parent function packet is that the domain is -infinity to 0, union 0 to infinity, because we have everything but x cannot be 0, and the range is the same thing. We have everything except y cannot be 0. Okay, so the next thing we did together is part of 4 is we're looking at these different equations and seeing how it changed from the parent function. Okay, so if you look at y equals -1 over x, well, what's the difference in these two is, of course, I have a negative sign. Is that negative sign inside or outside? Does it affect the x or the y? And I hope you all answered it affects the y, so we know that it goes on the outside. So this is just negative f of x. Okay, and you look at this next one, I have a -2 in here that's different from my parent function. And is that inside or is it outside? Does it affect the x or does it affect the y? Again, I hope you answered it's on the inside, it's affecting the x, so that's just my function. And I hope you realize that means that it moves it right 2 units. And then the last one, I think y'all got the idea now, that's going to be f of x plus 1 and then minus 3. So that 1 is shifting it right. Nope, fooled you. That 1 is shifting it left because we always do the opposite of what we see. And that negative 3 is shifting it down because with the y we do the same thing. So that's the one I actually want to graph with you and let you know what happens. So if I'm going left, my asymptote is now x equals negative 1. And if I'm going down, then my asymptote is now y equals negative 3. So what I'm going to do is I'm going to graph x equals negative 1 and y equals negative 3. And I don't have any other changes to it, so I'm going to go with those same key points, which I had 1, 1. And remember I said you're doing it from the point of intersection of your asymptotes. There's your negative 1. And remember, if we went 2, we had 1 half. And if we had 1 half, we had 2. So again, I'm going to do those. And that gives me some idea of what my graph is doing. Okay, like I said, I hope y'all do a better job of connecting those dots than I do. Not so easy with this device, but you got the idea. Okay, so if you turn your paper over, if you have it with you, okay, we have number 5, which is a word problem, and so we're going to do that together because I think most people don't remember what the volume of a cone is. So the volume of a cone is 12 cubic feet. Write the formula for the height of this cone in terms of the radius r. Graph this function over the appropriate domain. So first off, I write volume equals 1/3 pi r squared h. That's our volume formula. They told us the volume was 12 pi, so I'm going to put 12 pi in for my volume. And now it says write a formula for the height. So they want to know what the height is. So that means I got to get this guy all by itself. And to get him all by itself, I have to get rid of everything else on the side with it. So there's no addition or subtraction, so I'm not going to be adding or subtracting anything. I'm going to multiply and or divide. And I hope you see that the first one here is I have a pi on both sides, and if I have a pi on both sides, I can divide both sides by pi and get rid of it. And then a lot of y'all told me you knew to get rid of that 1/3, then I'm going to multiply by 3. So that's going to give me 36 equals r squared h. And then you know if I'm trying to get h by itself, we're going to divide by r squared. So I'm going to have h equals 36 over r squared. Okay, and if we sketch that over an appropriate domain, then keep in mind that our h is like our y, because that's what we solved for, so our r is over here. And what's an appropriate domain? If I've got the volume of a cone, then my radius, can my radius be 0? No, it can't be 0. Can my radius be negative? Can't have a negative radius of a cone. So my students figured out that r had to be greater than 0. And so we just took some numbers and plugged them in. So if I plugged in 1 for r, then I would get 36 for h. If I plugged in 2 for r, 2 squared is 4, and 36 divided by 4 is 9. And of course that means I should write a 9 and not a 4. 3, if I put a 3 in, 3 squared is 9, and 36 divided by 9 is 4. If I put a 6 in, so I'm thinking of numbers that would go into 36. So 36, 6 squared is 36, and 36 divided by 36 is 1. So if I plot these points, I have 6, 1. I have 3, 4. I have 2, 9. And I have 136, which is way off my graph. So if I connected these, and while I was connecting them, most students are able to tell me there's no way that this radius is going to be 0. That's just so bad looking. Sorry if I'm drawn too slowly. Okay, but it's looking something like this. Okay, and it can't be 0. So it's basically looking very similar to what we just did. And we talked about this particular problem is a word problem that has a real world meaning. So the radius can't be negative. But if it were negative, if I had negative values, would it change any of my output? And they figured out it wouldn't. So I would have this piece to it also. And that is where we get into our next parent function that you need to put into your parent function packet, which is to sketch the graph of f of x equals 1 over x squared. So again, we talk about those asymptotes, and our asymptotes are x equals 0 and y equals 0. And so I'm going to graph those asymptotes. And I have x equals 0. Okay, why did that happen again? X equals 0. Ah, okay, last time. X equals 0, y equals 0. Okay, now my key points, okay, we're doing the same thing. It's an over and an up like we had before. But if I put in, I still have 1, 1, because 1 over 1 squared is still 1. But this time when we put in negative 1, kind of like we were talking about up there, if I put negative 1, this is positive, so I actually get 1 again. So it's that mirror image that we talked about, or symmetric around our y-axis. Now watch what happens here. Before we put in 2, okay, just so we know how to extend it and understand. So if I put in 2, I get 1 over 2 squared, and 1 over 2 squared is going to be 1 over 4. So that means it's just actually closer than what we had last time. And if I put in 1 half, then that's 1/4, and 1 over 1/4 is 4. So I think it's helpful to know that this one is just going up faster than our 1 over 1x. Okay, and that's the, we won't talk about that. Okay, so do your best to sketch it and make it look, approach the asymptotes. That's the key thing. Get those points, know that it's going a little bit faster, and you're good to go. Okay, and similarly, excuse me, f of x. Look at the change. Okay, f of x equals negative 1 over x squared. So is that negative inside or outside? It's outside. It's going to affect our y. Look here, that 2 is clearly inside our parentheses, so you should know that that's going to, well, we'll talk about that one in a second. And this one, we said that 3 is on the outside, so we're going to have f of x plus 3. So that's what you're supposed to do there. And to graph it, okay, so what's happened is this has shifted my graph to the right 2 units. So now I don't have x equals 0, I'm going to have x equal 2. It did not shift up or down, so I still have my asymptote of y equals 0. So we're looking like this. And I still have my key points of 1, negative 1, going left and right, and up 1. And remember, if we went over 2, we were at 1/4 because it was squared. And if we went 1/2, we were up to 4. So there's really no calculating once you know those points, just knowing that this is steeper. But it took that parent function graph that we had and shifted it to the right. Okay? So if you have any questions about any of this that we've been doing, please email me or come see me. Okay, one last problem. And what I did on here, okay, write as a sum. That's like what you did on the first page. Graph that one right here. Write it as a sum. Graph it right here. I'm going to do this one with you. Write 2x minus 9 over x minus 5 as a sum. And then we're going to graph it right here. So that means, remember we topple it over. So I'm going to put 2x minus 9 inside. And my quotient, x times what equals 2x is 2. And that gives me 2x minus 10. And then when I subtract that, I get a 1. So my sum, if you want to write it down here, is going to be 2 plus 1 over x minus 5. And that's very similar to what we were just doing. So this 5 is going to affect the x. So my asymptote is now x equals 5. And this 2 is outside, so it's affecting that y asymptote. So I'm going to go graph y equals 2 and x equals 5. And it is 1 over x. It's not 1 over x squared, so my key points are over 1, up 1, and I go diagonally this time. And when I go to the 1/2, I go to 2, not 4 because it's not squared. So we have it looking like this. And I'm going to connect them to make them look like that rational function. So I hope that was helpful. And if you have any questions, again, email me or come see me. Okay, make that one approach your asymptote, and then we're good to go. Thanks for listening. Let me know if you have any questions.